Hello and welcome to another video. Today we're going to continue on with the Typescript line 75 and we're going to be doing find minimum in a rotated sorted array. So in this problem you have a sorted array that could have been rotated, doesn't have to be rotated, and here are some examples. So you can see this array was rotated, so it's 1, 2, and then it loops around 3, 4, 5, so it was rotated. And similarly this one was rotated and this one was not. So let's just take a look. So in this example the minimum is 1. So we have to return 1. In this example, the minimum is 0, so we have to return 0. And in this example, the minimum is 11. Now we're going to focus on this example first. So if we have 11, 13, 15, 17, this is going to violate the way we're going to do this problem, so we need to check for this beforehand. And so what we're actually going to do here is we're actually just going to check, is this value less than the last value or equal? I don't know if it can have duplicates. I don't think it can. So I think, yeah. And it might also be an array of length 1. So we can just check if the first value is less than or equal to the last value. And if it is, that means the array hasn't been rotated at all, right? So if the array hasn't been rotated at all, we just return the first value. And now let's look at some other examples and show you kind of why that is. So if the array was rotated, if we have like 3, 4, 5, 0, 2, the first value will always be bigger than the last value because essentially the way it looks is it's increasing, then there's some kind of drop where the rotation index is, and then it's increasing again. But this first part is always going to be bigger than the last part if it was rotated, because it's increasing, right? So if it was rotated, this part has to be increasing and then it has to loop around and it has to keep on increasing. So by definition, this value has to be greater than this value if it was rotated. But if it wasn't, like I showed here, then this will be the smallest value, so we can just check right away compared to the last value. Now, how do we find the smallest value if it's been rotated? So that part is going to be pretty straightforward, and let's just draw a bigger array to show this. So let's just say we have like just something like this, right? 6, 7, 8, 9, and we have 0, 1, 2, 3, 4, 5. Something like this. It doesn't have to be strictly increasing one number at a time. That can be whatever. So pretty much what we're going to do here is we're going to always compare it to the left value, and we know that this array was rotated, and that's why we need to check for this case, because if you didn't check for this case, this part wouldn't work, like our logic wouldn't work. So essentially what we're going to do is we're going to have a left and a right. So we'll have a left here and we'll have a right here and do a binary search. And any one of these could be the smallest value. This one can't be because we already checked if it was the smallest value if it was not rotated, right? So essentially we're going to check. So let's just get a midpoint here. So it's like 1, 2, 3, 4, 5, 6, 7, 8, 9. So the midpoint would be here. So we'll get a midpoint here. And first we're going to check, is this midpoint less than the value to the left of it? And if it is less than the value to the left of it, that has to be our answer, because in a rotated array, if you look, there's only one value that's less than the number to the left of it, right? So as you can see, it's this value here, right? So right where it's rotated, like the start of the sorted rotated array will be the number that's less than the number to the left of it. So once we get to the 0, that would be our answer. But in our case, it's not, right? So it's not our answer. But if it was, we can just return there. Now there's going to be two cases. So as I showed in the picture, there's going to be an increasing part, then it's going to drop down, and then it's going to be increasing again. So it's either going to be in this first increasing part or the second increasing part. And the way to know what part that's in is the first part, as you can see here, is going to be greater than the leftmost value. So we're always going to be comparing to the leftmost value. And any number here, not including this one, right, because we already checked for this number with this, is going to be greater than the leftmost value. And any number here will be less than the leftmost value. So it's really easy. All you do is just you compare your value to the leftmost value, and then you know where your smallest number has to be. And we know that the smallest number has to be to the right of the big part of the array, which is the numbers after the leftmost value, and it's to the left of the small part of the array, which is the numbers to the right of that smallest value. So we're just going to check for this middle part. Is it greater than or less than 6? Well, it's less than. That means that this drop already happened and we're in part 2. And we're looking, this is our x that we're looking for, this number here, right? The smallest number. So we're in part 2. So if we're in part 2, then we know our answer lies in part 1. So we have to go left. So if to go left, we would make the right over here. And we would do this again. So we're going to get a midpoint again, right? Midpoint's going to be over here. And we're going to check, okay, is this number greater than or less than the leftmost value? It is greater. That means it has to be in this left peak over here. That means our answer has to be to the right of it. So if the answer has to be to the right of it, we're going to make the left over here. That part is pretty straightforward. Now we get a new midpoint, which is over here. Now we're going to check, is that greater than or equal to 6? It is greater than 6. So totally fine. That means we need to go right. So to go right, now our left and our right are finally at this same value. Now we only have one number left. Okay. And now this number is going to be, in fact, less than the number to the left of it. So that will be our solution. So when we check for the number to the left of it, this number will be less than it, and it'll be our solution. So that's pretty much all you have to do for this problem is you have to recognize that your graph looks like this, or your array looks like this, increasing, 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 drop, increasing, increasing, increasing. And let's just call this the leftmost value, and this is the rightmost value. This leftmost value will be less than this whole chunk, and it will be greater than this whole chunk, so it's very easy to figure out what chunk we're in using that. And so now we have enough to code it up. And there is actually a problem that relies on this to do something else, but maybe we'll go into that later. Okay. So let's code it up now. Let's full screen. So essentially, first, what we have to do is we have to actually check if it's sorted already. So let's do that first. So if nums 0, it could be a length 1 as well, right? So if nums 0 is less than or equal to nums dot length minus 1. So there we go. Then we can just return the first number because it has to be there, the smallest number. It's already sorted. Okay, now we have to get the rest of it. So left equals 1, right equals nums dot length minus 1, right? And we can start at 1 because 0 can't be the answer, otherwise it would have been already sorted. So now we just do a normal binary search. While left is less than or equal to right, we are not Python, classic. So we get a pivot value. So should be able to use const, I think. Const pivot equals left plus right over 2. And because it's not Python, we have to map out for that to get the binary search. Now we simply have to check our cases, right? So let's check the first case. So if nums pivot is less than nums pivot minus 1, that means we have our answer. Return nums pivot. Otherwise, let's check our other two cases. So if nums pivot is greater than nums of the first number. So if it's greater than the first one, it's on the left side of the array, right? Just like in our picture. If it's greater than the first one, it's on this side, so we have to go right. So we will do that. So we can just say left equals pivot plus 1. And finally, else we can do right equals pivot minus 1. Okay. And we're guaranteed to get an answer in here, so we should never like be out of bounds or anything. We can return -1 or something, you know, just to make sure, like, if you do get a TypeScript error, you can return something as a default. But theoretically, you should basically never get to this part. So let's see what happens. Let's actually get rid of this. Okay, so you can see it's reasonably efficient, and yeah, it's like all over the place as usual for TypeScript. So anyway, let's go through the time and space for this one. So for the time, we're essentially doing a binary search through the array, right? So like this part is 01, so that's fine. but we're essentially doing a binary search through the array, so that's going to be a log of n. And for the space, we aren't making any new arrays or anything, right? We're making a left and a right as always in a binary search. So the most typical binary searches are a one space unless you make some new variable. And I think that's going to be it for this problem, actually. So hopefully you liked it. Quite a short one. And yeah, this problem is part one of find a number in a rotated minimum sorted array instead of finding the minimum, in which case what you would do is you would find this minimum and then you would break your array into two parts and figure out where your number is, and then you would binary search on that one. So essentially that one's like two binary searches, also a common interview problem. I believe this one is also a common interview problem, reasonably enough. So definitely good to learn. I think it's a must know for sure. So make sure you do. And yeah, that's going to be all for this one. So if you'd liked it, please like it and subscribe to the channel. And thanks for watching. I'll see you in the next Typescript video.